record. Okay, so we're going to do question 2, page 46, limiting equilibrium. It's this question here. Right, let's move that out of the way. Okay, so it says a child has a toy of weight 100 newtons and it's attached to a string. So here is my toy. It is attached to a string. The toy is initially at rest on a rough horizontal ground. So we draw in our rough horizontal ground. That's our little sketch. And the child picks up the string and pulls it so that the string makes an angle of 16 degrees with the vertical. Okay, so here's my vertical, and it's going to make 16 degrees with the vertical, 16, and the child pulls. So I'm going to model that as a tension there, because it's a string, so it will be in tension. Okay. Now, what's the weight of the toy? 100 newtons. So it's quite a heavy toy, 10 kg. 100 newtons going down. If the coefficient of friction between the toy and the ground is 0.8, so let me just write that in, mu equals 0.8 for this surface, and the toy is in limiting equilibrium, find the tension in the string. So, the toy is about to move this way, and if it's about to move to the right, it means the friction is going to act to the left. And the value of the friction is mu times r. Now, r is the normal reaction. We've got the weight here, we've got the tension of the string, we've missed out the normal reaction. Let's put that in there. So we have a force here, which is r. Okay, now that angle there's still 16. Let's clean this diagram up with something resolved. So here we have the toy as a particle. We've got r going up. We've got 100 newtons going down. Here we have mu r. Now, my tension I'm going to resolve into two forces. One of them is going to go up, and one of them is going to go along. So this one is going to be T, and it's sine 16, and this is T cos 16. Okay. Now, to find out the value of the tension, which is the question, we need to write out two equations. The first equation is going to be horizontally. We can do that. And we can say that T sine 16 is equal to mu r. We know mu is 0.8, so T sine 16 is equal to 0.8 r. We don't know r, we don't know t. If I do this vertically, I've got r plus T cos 16, and that's equal to 100 newtons. So 100. Again, we've got an equation, we don't know r, we don't know t. So from this equation and from this equation, we've got two unknowns and two equations. We can solve them with simultaneous equations. Now, we've only been asked to work out t, so I'm going to substitute r. So if I label that equation A, from equation A, I can say that T sine 16 divided by 0.8 is equal to r. And I can sub this into B. B, I can take my value from this, which is r, is T sine 16 of 0.8. Am I still on the page? Just. Plus T cos 16 is equal to 100. So we would have to, I'm going to just run out of space, so I'm going to start here. So T times sine 16 over 0.8, factorizing this, plus cos 16 is equal to 100. T is equal to, oh, that went off the page. T is equal to 100 divided by all of this. and use your calculator and you get an answer. T equals. Okay, so the answer's given. Student answer is 76.58. That's probably correct. 74.8 is the answer given in the back of the book, but we think there may be an error in that.